Okay, so here we are in chapter 3, which is about relationships between categorical variables. So we begin with this idea of, if you see this example that I've got here, we've got this idea that we've asked two questions at the same time, okay? So we've asked two questions. So two questions are being asked. Both are categorical, just so we're clear on what's going on here. So remember from chapter 1 that categorical data are, they can still be values, right? But they don't have measurable units. So typically these are questions that we answer like yes or no, or we have some other kind of answer that goes along with it. So in this case, we asked just a few faculty members on campus. This is just a basic example. We said, how are you holding classes? Right? So the first question, which is across the top, says, how are you holding class? So we gave them the choice of online or hybrid. And the second question that we asked was, what department do you teach in? Okay, so we have either math or science. So it's a really short little survey here. This particular table, which displays the distribution, so this is the display of the distribution of two categorical variables at the same time. This is what we see on our left, which is referred to as a contingency table, which is our first kind of vocabulary word that we have here. It's, in this scenario, this is going to be any table that we see from now on until the very end of the class, these tables exist all the way through the end of Unit 3. And they're always going to have two categorical variables displayed at the same time. So something on the rows and something in the columns. And within this table, for instance, the number 4 refers to the students who are taking math online. So within this table, each cell represents the answer to two questions at the same time. So one thing, I'm just going to switch colors here. One thing that we want to think about here are the totals along each of the rows and each of the columns. So what I'm going to do is total each one of these columns. So 4 plus 2 gives me 6, okay? So let me rewrite that so I'm not writing all over the board. And then I'm going to add these two, we get 16. I'm going to add those together and we get 22 over in the bottom corner. So let's double check that that's what we get on the top. 4 and 7 is 11, and 2 and 9 is also 11, which makes 22. Awesome. So what we have here in red, okay, is the marginal distribution. Okay, so I like to think of it as the margins of the table, right? So the marginal distribution is the distribution of one variable from a contingency table. I'm using a lot of abbreviations here because I want to make sure that we fit the major definitions on one slide here, and then we can go to the next slide to see the final piece of information for this chapter. All right, so the marginal distribution is the distribution of only one variable. So an example might be the marginal distribution of, and then we could pick one of the categories. So class type. Okay, so in this case, we would have two different class types. So I'm going to go below here for this example. So the marginal distribution, or I guess I can just go right here next to it. we would have online and then hybrid students, okay? So we have the marginal distribution of class type. In this case, we have online and hybrid. Those are our two class types. And then we have the total number of people that we surveyed, okay, or the total number of faculty. So I always like to begin by putting denominators here because most of us will make the most sense out of this. I think my Apple Pencil just died. Most of us will make the most sense out of this if these are expressed as percentages. So let's see if we can express this as a percentage. There we go. So 22 is on the denominator, and for all of these here. 22 here, and another 22 here for the total. And then we want to look at how many people took online classes total in the survey, are teaching. How many people are teaching hybrid classes? And then we also like to look at, to make sure that we've actually added these up and gotten the correct total. So I'm going to take out my calculator, and I'm just going to figure out what each of these are as a percentage. So this is about 27%. I'm just rounding to the nearest whole percentage. This is about 73%. It's actually 0.727. So, and remember that I would find this number, I would multiply by 100 to convert it into a percentage. And then these two numbers do total, in fact, to 100%. So we could say, in this particular example, that 27% of the faculty are teaching online classes and 73% of the faculty are teaching hybrid classes. If I had asked for the marginal distribution of the department that you teach in, it would be a lot less exciting because both of those are 11 over 22, and that's not as intriguing. All right, one more new color here. I'll go for this bluish teal. I'm going to define one more new thing on this slide, and I'm kind of going to box it in, and it's going to be, there are multiple conditional distributions here. So let's hope this isn't the worst color I've ever chosen. The conditional distribution, okay, so it's going to end up being a single row or a single column from the table. So I'm going to outline one of these, but there are 4 separate conditional distributions here. So I'm going to just pull a circle around one of the rows, okay? So back to the black so we can see what I'm writing here. Now the conditional is in teal. So this is going to be the distribution of one variable with respect to another, okay? So we've chosen a category in one variable, and now we're looking at the others. So think about what we've chosen here. I'm kind of going to draw a little bit, I hate this, that I'm doing this, but I'm doing a little line here because I want to make sure conditional is totally separate from marginal. All right, so it's the distribution of one variable with respect to another. So in this case, and I will go to the next slide to make sure this makes sense, but in this case, I have circled the conditional distribution of, and then take a look at which categories are within the table, right, that I've circled through, and that's online and hybrid. So the conditional distribution of class type for the, and now we need to be specific. I've circled specifically one department. So this is the conditional distribution of class type for the math department. The second row would be the conditional distribution of class type for the science department. Okay? So what I'm going to do is go to the next slide here. So I'm going to go to slide 2. And what we had in our first column, or first row, excuse me, were 4, 7, and 11, if you guys remember. And this was online, hybrid, and this was math, okay? So just a reminder of what we had, and then below it we had science, and we had 2, 9, and another 11. So just a reminder of what our little table looks like, okay? So why did I not write the totals at the bottom? Because we were doing the conditional distribution of class type for the math department, right? So we've already singled out, I'm going to use the same color one more time, this group of people right here, which means that when we do this example, we again have the same, let's spell it right, online and hybrid, as well as total. Those are our 3 categories still, because we're still talking about class type. These are my categories. But then this, whatever we signify at the end, this is where we achieve this idea of our new total for the conditional distribution. So now we're only talking about the faculty that teach math. And so in all of these, that's the 11 that's right here at the end of that total. And then our numerators are the other 2 numbers that we got from within the table. And then we total them again to make sure that we see that this is really 100%. So we're going to explore this one more time. 4 out of 11, I'm just going to round these to the closest percent, is 36%. And then 7 out of 11 is about 64%, which does total to 100%. So we're good. Okay, final definition. Sorry, this is a long video. We have one more definition. I really did think it was going to be short. It's called independence. It's because I had to do examples for everything. Okay? Say 2 variables are independent if their conditional distributions are identical. Okay? So in this particular situation, we've found one conditional distribution. So I'm going to continue this with finding the second conditional distribution that would need to be compared in order to kind of discuss independence within this table. So look, above we found the conditional distribution of class type for math. So we're going to do of class type for science. And that means that we're going to list the same class type. So online, hybrid, and total. I'm going to use abbreviations here. And we're now talking science. So a little bit confusing. None of my denominators changed. Let me erase this little guy here and here. Okay. So none of my denominators changed, but both of my numerators changed here. So this becomes 2 faculty teaching online, but 9 teaching hybrid in the science department, which means if we look at these percentages, we've got 18%, and just to double check, we got about 82% here, which sums to 100%. So what we would say is, because the conditional distribution of class type is not the same for each department, the variables are, and then we would just say not independent, right? So in this case, we've shown that these particular variables are not independent. So guys, I know this is weird wording, but this actually means, you know, the idea here is they're dependent or they are related in some way. Okay? All right, that's finally it. Sorry this took so long, but those are your notes for chapter 3.